Okay, so when we left off, you were going to take a look at how to do these categories. You're going to take a stab at it. These are the answers. So if you were asked to create categories of width 10, starting at 50, that means that your first category starts at 50. The next one after that starts 10 more than that, so 60. The next one starts 10 more than that at 70. And then something similar here. The first category would start at 500, and then the next one would start 20 higher than that. And then you stop at 519 just to make sure that, because you don't want the categories to overlap. All right, so that's that. Let's talk about some of the shapes of the distributions. There are kind of some prototype shapes, and let's talk about kind of what they represent. This one, part C, is the one that we saw a minute ago. This one is where most of the values are in the middle, and then we've got fewer ones off to the sides. So fewer observations are low and fewer observations are high, and the farther out you get from the middle, the less common the values are. So pause a minute and see if you can tell what each one of these tells about the data set. All right, so this is what we see. For this one, part A, all of the values of the variable are pretty much equally common. This is what you might see if you're rolling a dice a bunch of times, where you have the same number of 1s as 2s as 3s. For B, you've got most of the observations are low and fewer of them are high. D is the opposite. Most of them are high and few of them are low. And the lower the value is, the less common it is. We already talked about C. And then E, you've got something that really has two peaks. And these peaks don't necessarily have to be the same height, but you've got two distinct peaks. So you've got a clump of observations that are low. Down here, you've got a clump of observations that are high, and not much in the middle. That might be, if an example of that tends to happen on tests a lot, where I'll get a lot of A's and B's, and a lot of D's and F's, but not a lot of C's. So that's an example of a distribution that looks like that. Each one of these prototypes has a name, and I want you to be familiar with these. This one, where all the bars are about the same height, is uniform. This one with the long tail out to the right is called right skewed. This one with the long tail to the left is left skewed. This one here is bell-shaped, or approximately normal. And then this one is bimodal. So it's got two peaks, so it's bimodal. You can have more than two peaks, and that would be multimodal. And like I said a minute ago, the peaks don't have to be the same height for that to be the case. So make sure you study these and can identify the names when you see them. So those are the general prototypes. However, when you look at distributions of actual data, they rarely fit one of those exactly. So let's look at some examples. These are from a crime data set that I looked at. And this is what histograms generated in SPSS look like. You'll see some of those later in this week's lesson. So this one, you kind of have a second peak over here. So if you tried to call that bimodal, I'm not sure I would count that wrong, but I wouldn't really put too much stock in this tiny little bump here. Overall, I would say that's probably skewed to the right. And I try to be lenient when I'm grading these, so if you give something that's reasonable, that can be justified for the histogram that you're looking at, that's okay. But that one I would call skewed to the right. This one here, You could make an argument that it's skewed to the right. I would say for the most part, though, it's kind of bell-shaped. But if you said that skewed to the right, that would be okay too. Here's one that I almost wouldn't even try to categorize it. You might say it's multimodal. That would be okay. I guess that's the closest thing to it, because you do have kind of 2, maybe 3 distinct peaks here. But you see that these don't neatly fit those prototypes. But like I said, I would probably call that one multimodal. As you go through these histograms, I want you to keep in mind the histogram itself is not the point. It's what you get from the histogram. So it's so that you can look at the distribution of the data. You can see where most of the data is. Is most of the data in the middle? Is most of it low? Is most of it high? Do you have just 1 peak or 2, or is there more than that? Okay? All right, so that's it for this lesson.